All right, we're going to move on to continuing with our trigonometry unit, and we're going to graph the sine and cosine functions. So you can go ahead and pause if you'd like to read this. What we're going to focus on is the symbol x rather than theta or t to represent the independent variable. The symbol y will represent the dependent variable. Thus, we'll be graphing y equals the sine of x and y equals the cosine of x in the rectangular coordinate system. So this is a rectangular coordinate system. This is our x-axis, and that's our y-axis. And what you're going to see is most graphs are measured in radian measure, not in degrees. So here's the first graph, y equals the sine of x. We call this the parent function for the sine of x function. So if we think about the unit circle, and there's all those points around the unit circle, if we look at the first ordered pair 1, 0, and then 0, 1, -1, 0, etc. What we can do is we can find these ordered pairs around the unit circle. So let's say something like this first ordered pair. Where is that on the unit circle? The x is your angle, and then the y is when you evaluate it. What would be the output? That would be the ordered pair piece. So we're going to be focusing on the sine. So sine on the unit circle is the y values. So this first ordered pair at 0 degrees outputs 0. Now let's go to pi over 2. Here is pi over 2. The output is 1. Then we'll go to pi. Here is pi. The output is 0. Then we'll go down to 3 pi over 2. At 3 pi over 2, the y value is -1. And then we continue 2 pi. The output is 0. So let's graph these ordered pairs. So the first one, 0, 0 is right here. At pi over 2, 1, we're up there. At pi, we're at 0. At 3 pi over 2, we're down at -1. And then at 2 pi, we're at 0. So these are 5 coordinates that we graphed. Now there are more ordered pairs between these 5 coordinates. And what happens is when we connect those dots, we're going to get a sine curve that looks like a wave. The period, which we call the length of a 1 revolution, is 2 pi for a sine function. The amplitude is going to be 1. Now this graph does go on in infinitely many cycles. So I'm going to highlight this first revolution, this first cycle that we drew on this previous slide. Now what happens is it just continues another revolution, backwards another revolution. So notice the distance between these is a period of 2 pi. The distance between these two is another 2 pi. Distance between these two is another 2 pi. Please highlight that the domain of a sine function is all real numbers. Its range is -1 to 1, so that's your y values. The period is 2 pi, and it is an odd function. There will be some variations from the sine function, so we call these transformations. So they're like the children, the change from the parent. So here are some steps that we'll follow on further examples. So you can pause if you'd like to read those steps. Two things that are important to find the amplitude. It is the absolute value of a, what happens in front of that function. The period, the length of a revolution, is 2 pi over b. So the period is how long one cycle occurs. The amplitude is the height, and half of it. So we're going to go ahead and graph that parent function one more time. So I'm going to start with 0 and then 2 pi. Then I'm going to split this in half at pi. Split it in half one more time. Pi over 2, split in half again, 3 pi over 2. So when you graph your sine and cosine functions, you're going to split that x-axis up into 4 equal increments. Now the height, I'm just going to make this up 1, 4 boxes, and then down 1. And I'm going to start to graph those ordered pairs. So this first ordered pair is 0, 0. I'm going to skip to that order pair of pi over 2, up 1. At pi, we are at 0. At 3 pi over 2, we're down to -1. And then at 2 pi, we're at 0. And now we're going to create our curve. So this would be 1 revolution for the parent function. In a further example, we'll start the transformations of that sine function.